A rock is thrown upward from the top of a 112 feet high cliff overlooking the ocean at a speed of 96 feet per second. The rock's height above the ocean can be modeled as h equals to negative 16t squared plus 96t plus 112. A, when does the rock reach max height? And B, what is the actual max height? And C is when does the rock hit the ocean? Actually, I'm not too sure if I can do this. I guess I can do it. Right. Now, one thing I want to say before solving this is that it's amazing that if you model things that go up and down, it actually shows a parabola. The reason that math is very popular against what you think it is, math is really popular because so many things obey the laws of mathematics. Like, who would have thought that something that's going up and down would actually follow a quadratic function? But it does, right? And because math just pops up in so many different places, knowing math really gives you the advantage. In fact, the reason that the science of the Western countries advanced so much was because Newton was able to quantify everything and write the equations for it. Once you had the math to describe the science, then afterwards it just became so much powerful. So, yeah. Okay, so let's actually solve this. Basically, this is what it's saying. You have some cliff, and the ball is thrown upwards and it came down, and it's like, yeah, splash. And that's what's happening. When does the rock reach maximum height? Well, if you draw the graph of time versus the height, it starts at 112, right? Because if you plug in t equals to 0, that's where it starts. And then, because you threw it up, eventually it starts going up and up and up, and there is this time, I don't know when, that reaches the maximum, and then it starts to fall down. Okay? That's the graph. So we are looking for this point, but what is this point? That's the vertex of the parabola, right? Yeah. So how do we get the vertex? We use the vertex formula, which is negative b over 2a. Right? That's the formula for the x-coordinate of the vertex. So let's plug things in. It's negative b is 96, twice of negative 16. So negative times negative is just negative cancels. Twice of 16 is 32. And 96 divided by 32 is 3. Okay, so the answer to the first question is 3. At 3, time t equals to 3 seconds, it's going to reach the maximum, and afterwards it's going to fall down. Right? Now, what is the actual maximum height? Well, you just have to know the height at 3, right? So to answer part B, you need to compute h equals to negative 16, 3 squared, plus 96 times 3 plus 112. That's 9 times 16, that's negative 144. 8, 27, 28, 8, plus 112, so that's 144 plus 112, which is 256. Okay, great. So the max height is 256 feet above the ground, above the ocean. Because the h is the height above the ocean, so it's 256 feet above the ocean. Okay. So really, the max height should be 256, but to be more exact, I would also write above the ocean. Or from the ocean, 256 feet above the ocean. Now, when does the rock hit the ocean? Now, if the rock is actually at the ocean, what's the height?
0.
Height is 0. So in other words, this part C is asking for the time when h is equal to 0. In other words, it's just like the x-intercept. It's slightly different because if you really drew the entire parabola, there's this parabola side from negative time, but negative time is not physical, right? Only after it's thrown, the real thing exists. So if you get the two x-intercepts, you only take the positive one, not the negative one. That's what you have to do. All right, so let's try that. Let's try to see when h is equal to 0, plus 96t plus 112. I thought this was very big and hard to factor, but I realized that everything is divisible by 16. So let's do that. Just divide everything by 16. The 0, or actually by negative 16, so this becomes positive. So it's t squared. 96 divided by negative 16 is negative 6. I'm not so sure about 16, 112. You know what? Let's not do it this way. 112 over 16. Divide top and bottom by 4. 4 times 2 is 8, and then 32, yeah, 8, right. And then 28 divided by 4 is 7. Okay, so it's 7. Okay, so if you divide by negative 16, it should be negative 7, yeah. I was about to change that. Thank you. All right, so you have this, and now you can factor this. It factors as t minus 7, t plus 1. So that gives you t equals to, either t equals to 7 or negative 1, but we throw out negative 1 because that's not physical. So t equals to 7 seconds. Okay. So the answer for part C should be 7 seconds. By the way, I probably forgot this. In A, when you write 3, you should also write 3 seconds because you have to include units for these word problems.